Hi everyone, this is Dr. Smith. We're going to have a presentation now and a lecture on pesticides and other organic chemicals. This will be one of the longer presentations because I'm combining both of those into one lecture. I think it's fascinating because these are, again, ubiquitous, similarly to the metals, although most of these are of human origin, and so we have a whole different aspect with respect to their creation and usage in the environment and with respect to human health. So the things I'd like you to be able to do by the end of this lecture are list some common substances that are included in various pesticide and organic chemical groups, name at least 3 of the commonly used insecticides and herbicide, name some organic chemicals of concern that are persistent in the environment and pose exposure and risk to humans, discuss some of the health effects of exposure to pesticides and organic chemicals, and also be able to name and categorize pesticides and organic chemicals that are relevant to environmental health and assessing potential risks. So let's start out with kind of some fundamentals here and talk about advantages, disadvantages. You know, we typically hear things like all chemicals are bad and we should do away with all synthetic organic chemicals. Let's talk just briefly about some of the advantages, and we'll talk about some of the disadvantages, and we'll go into some detail about both. So, it's interesting because we have created so many chemicals. There are naturally occurring chemicals that we still use, but there are a lot of synthetic chemicals that through ingenuity and engineering and chemistry we've created that have become essential to the functioning of our modern society. Some would argue that they are essential and that we can find alternatives, and there's a huge movement now to look at alternatives to some of the more hazardous synthetic organic chemicals and pesticides in order to try and reduce the impacts that these have on human health and the environment. As of 2010, there were over 15,000 chemicals made and used in high volume, and when we talk about high volume, we're talking about millions of pounds of these chemicals used in the United States for manufacturing clothing, computers, cars, phones, building materials, rugs, etc., and also the use of pesticides for agriculture and prevention of disease. Some of the disadvantages, but before I go on to that, let me just say some of the advantages are that used properly and wisely and discreetly, they can be of significant advantage. We'll talk more about that, especially with respect to prevention of disease when we get a little more into the pesticides. But there are also clearly some disadvantages of the use of these synthetic organic hazardous chemicals. They are clearly implicated as human health hazards for example, in the etiology of cancer and adverse birth outcomes. We have direct link to some of these things. Silent Spring, a book written by Rachel Carson in 1962 about DDT in the environment, is credited with the beginning of sensitizing the public to the potential hazards of chemicals that were being widely and indiscriminately used in the environment. And so there are huge examples of where the use of chemicals such as DDT were so widespread because of the benefit they brought of controlling mosquito vectors and other insect vectors of disease, that the cost versus the benefit was thought to be reasonable, and so the compounds were used. It was only later, after time, that we found out some of the downsides of such widespread and indiscriminate use. So as I said before, I think that there are benefits. We need to be discriminating, and we also need to be looking for alternatives to those things which have particularly bad impacts on the environment. A brief sort of chemistry lecture background, because this will be important in you understanding some of the categories both of pesticides as well as the synthetic organic chemicals we'll be talking about. Some of you have chemistry background, some of you do not. So what I want to talk about, and these are very important concepts, is that there are certain things that are very widespread and widely found in the manufacturing and the structures of some of these things, including an aromatic compound, which is essentially a benzene ring. If you look on the far right of the slide, the six-sided figure with the little lines inside is benzene. But these are chemistry structures that have allowed us to make many different kinds of compounds, ranging from pesticides and solvents to dyes and pharmaceutical compounds that have brought wide benefit to humanity. In talking about organic compounds, we talk about hydrocarbons. A hydrocarbon is an organic compound like benzene, which we just saw, acetylene, butane, which we've heard, which contain only carbon and hydrogen, and often occur in petroleum, natural gas, and other things, and different kinds of coal like that. This is an important concept as well, because in combination with carbon and hydrogen, with oxygen, with other compounds such as nitrogen, we can make many things. Now, the important distinction here is to realize that anything that's called an organic chemical is not necessarily a bad thing. They are naturally occurring, such as sugar or other organic things, food substances, alkaloids, things that within our own bodies that are organic chemicals. It's some of the synthetic organic chemicals that have tended to be problematic for us as we've developed them and used them very widely. And as we get into talking about this more and more, one of the things that is creating a broad environmental hazard is the fact that a lot of these organic chemicals that are synthetic are very persistent in the environment, persistent organic pollutants, or POPs. These are toxic chemicals that have been shown to adversely affect human health and the environment worldwide. They are, and they have been, they are, and they can be transported widely through natural processes as wind, water cycling, and other things. And they can and do affect wildlife, and people very distant from where they're used and released. And so we see things like burning of high sulfur content coal in China, and detection of the residue of that coal. It can be traced molecularly in the snowpack in the Rocky Mountains in the United States. We know that DDT is widespread, and there's virtually no organism on this planet at this present time that does not have some level of DDT and some other persistent organic pollutants in its body, even though DDT was banned a number of years ago, and we'll talk about that more. Just to kind of get you in the chemistry groove, here is the structure of DDT. It has a very long chemical name, but this is, and you'll see there are a number of little things that say Cl. Those are chlorine molecules, and those tend to make it very resistant to breaking down in the environment, and therefore a persistent organic pollutant. So we'll move on into pesticides first, and we'll talk more about the general categories of organic chemicals in a minute. Pesticides. A lot of people talk about pesticides and they think insecticides only, but a pesticide is a very broad category. It's any substance or mixture intended for preventing, destroying, repelling, or mitigating pests. And pests can be insects, rodents, weeds, and a host of other things like mold or microbes. All of those kinds of things. There are large numbers of categories of things that fall under the general classification of pesticide. So we'll talk specifically about insecticides, which are those compounds used specifically to prevent the growth of or kill insects. Herbicides, which are designed to control or destroy plants, weeds, or grasses. Fungicides, that are used to control, deter, or destroy fungi. Rodenticides, anything that is used to destroy rats or rodent pests to prevent them from damaging crop foods or spreading disease. And nematicides, these are things that are destructive to nematodes. Nematodes are very tiny worm-like creatures. They are essentially ubiquitous in the environment. Some of them are very beneficial, some of them are very destructive. Primarily, we look at nematicides in the context of agriculture, because there are a number of very potent nematicides that can destroy major crops, and so nematicide use. There are other categories as well. As I said, there's things like slimicides and molluscicides, slime preventers and mollusk inhibitors that are used on the hulls of big ships to prevent barnacles attaching, which slows the ship down and costs a lot of money and fuel and things like that. So we have a wide range of pesticides, and we'll talk about some of the major categories here as we move forward. Let's start with insecticides, and there are really 4 major classes of insecticides derived from organic chemicals that we want to talk about. Interestingly enough, there are a number of insecticides that are of natural origin that have been used for centuries to kill insects, and we still use some of them today. One of the most potent of those is nicotine, and you can find insecticides that are nicotinic and derived from natural sources such as tobacco that are very toxic to pests and also to mammalian species. But we're going to focus primarily on the organic chemical side. We'll talk about organophosphate, organophosphorus insecticides, carbamates or organocarbamates, organochlorines, of which DDT is one, and pyrethroids, which come from a naturally occurring substance called pyrethrin, which is found in certain plants. Organophosphate pesticides, and these may be some of the most familiar to you. These act by inhibiting cholinesterase, which is an enzyme found in insects and mammalian species and birds, and a lot of different animals. They're used to control a wide range of insects, and this eliminates the need for multiple applications of different pesticides. So this was viewed as a cost benefit. So you can put down a organophosphate pesticide, kill off all the bugs, and not have to worry about picking a different pesticide or a different insecticide for this type of bug or that type of bug. This is interesting because we think about, in the context, we think about antibiotics, for example, and they're, one of the big problems we have now are resistant strains of antibiotics. Use of these organophosphate pesticides over the years has not created any kind of resistance in the insects. They tend not to persist in the environment, which is an advantage. However, they are very toxic to humans, other wildlife, and livestock, and so they can and are one of the most frequent causes of fatal poisonings in humans and suicides, because they are so highly toxic to a wide variety of species. So there's some benefit and some cost here. There is no resistance. They don't persist long in the environment, but they are highly toxic to a wide range of things beyond just the pest category. Excuse me. Some of the effects, as I mentioned earlier, organophosphates work, as do carbamates, by inhibiting an enzyme called cholinesterase, which breaks down a neurotransmitter in the body called acetylcholine. This is found in many, many species, including insects and humans. And this anticholinesterase activity happens almost immediately after exposure. And so it's a neurotoxin. It breaks down the ability of the nervous system to send nerve impulses, and essentially causes a paralysis, and paralysis both of the muscular system and the respiratory system. So these are acute effects, and again, they happen very quickly. Just a side note here, organophosphates are not only used as pesticides, they were transferred into another use category that many of you may know as nerve gas or nerve agents. And so the military adopted a lot of these things and created even more potent compounds that are used agriculturally or for insect control as weapons of war, essentially. And these are again highly toxic. You might remember the sarin attack in Japanese subway a few years back, but these are very, very toxic compounds. They're very rapid acting. They also do have some long-term effects, however, and those can include a condition known as organophosphate-induced delayed polyneuropathy, or OPIDN. And this is manifested essentially by neurologic symptomologies, numbness, loss of sensory abilities, and weakness. But this is not apparently related to the acute effects of direct anticholinesterase activity from these organophosphates that cause the death when used as a pesticide. So there's chronic effects that come out and attack the nervous system in a slightly different way. Some organophosphates you might recognize the names of or should be familiar with: diazinon, malathion, methylparathion, and parathion. These appear in a wide variety of products, even still. Most of the things you will be able to find will be for treatment of bugs in your garden or treatment of fleas on your pets. And so there are sprays and baits and indoor foggers, flea collars, pet shampoos. These are not probably the most healthy thing to use on your pet. Fortunately, most of the things that are used as flea control and things like that inside a home dissipate relatively rapidly. And so you don't, once they're used, if pets and children and people are kept out, you're not going to experience high concentrations of these after the time that's stated on the label, because they essentially break down in the oxygen environment with sunlight and oxygen. Malathion is one you'll see a lot. It's a direct application for a lot of food crops. Diazinon, methylparathion, and parathion are very, very potent, used primarily in agriculture and are actually very limited in their usage right now. They've been downgraded because of the toxicity, mostly to farm workers and other species such as migratory birds and things like that that can occur in agricultural settings. I mentioned that there is a class called carbamates. These are closely related to their organophosphates from their mechanism of action. Typically not as potent. They break down very quickly in the environment. And there's a lot of these things that are around still that are approved for garden and also for pet control of pests in gardens, and also for ticks and fleas in your pets. 7 is a trade name: carbaryl, aldicarb, phenoxycarb, propoxyr, and metamsodium. Metamsodium is actually an intermediate in the production of other things. And let me talk about intermediates in the production of carbamates and organophosphates, because we think about the end product a lot as being the most toxic thing, but truthfully, the things that are used to manufacture these can be highly dangerous as well. And one thing I want to just talk about briefly was methyl isocyanate. It's an intermediate chemical used for manufacturing carbamate pesticide. It's extremely toxic because it is a cyanide-containing compound. It's not an organophosphate or a carbamate. It's an intermediate compound, but cyanide-containing, also an organic cyanide compound. And so it's highly toxic. It's highly volatile. And some of you may also be thinking at this point, that sounds familiar. And the reason it sounds familiar is because methyl isocyanate was released from a manufacturing plant in Bhopal, India, and killed more than 3,800 people because of the toxicity. This was a manufacturing plant for carbamate insecticides and some other industrial chemicals. It released this intermediary, methyl isocyanate, into the air in this community one morning, and thousands of people died. And this has led to increased control over manufacturing processes, both in the United States and in other countries where these things are manufactured. It killed 3,800 people, but it also killed several thousand livestock, chickens, goats, etc., and got into a nearby stream and killed thousands of fish as well. It does not persist long. It is highly acutely toxic, but this was a tragic accident. Again, one of those kind of noteworthy things we remember about the costs and benefits of pesticides and industrial chemicals in general. Organochlorines are the second big category I want to talk about briefly. Derived from chlorinated hydrocarbons. You remember back to the first of the lecture where we showed the chemical structure slides. These are chemical compounds that contain chlorine, carbon, and hydrogen. Interestingly enough, and I mentioned that briefly earlier, that the chlorine tends to make it very stable in the environment. It also tends to make it very lipid soluble or fat soluble. And so persisting in the environment and bioaccumulation in the food chain occurs through storage of these residues in the fat tissue of an organism, be it a fish or a human being. In humans, organochlorines are associated with a lot of different things depending on the dose and the exposure, but primarily immune system depression and cancer. And so some examples of this category can include DDT, which we've seen already in the structure for, and related compounds such as lindane and chlordane, Mirex, hexachlorobenzene, which was widely used as a surgical scrub for a long time until it was found out to be neurotoxic and also potentially carcinogenic, and methoxychlor. These are just some names. We'll talk a little bit more detail here, primarily about DDT. DDT, dichlorodyphenyl trichloroethane. Widespread use of this compound, of this insecticide, began early in the 1940s and reached a maximum in the 1960s. And again, you'll see here that the reason it was studied more and eventually banned in 1972 in the United States is because of the work of Rachel Carson and others, showing that even though it was very effective against mosquitoes and other insect vector-borne diseases, in preventing those insect vector-borne diseases, it accumulated, and Rachel Carson pointed out primarily that it accumulated up the food chain because it would be sprayed widely, it would get into the water, the streams and the rivers. It would be then uptaken by the food chain, so the invertebrates get exposed to it, absorb it, the fish eat the small invertebrates, the larger fish eat those fish, and then the raptors, primarily the bald eagles, would eat the fish, and other things too, peregrine falcons. And this led to, after a lot of research, the fact that DDT was inhibiting the formation of eggshell thickness in these birds, and so they were so brittle that when they were laid by the bird, they would break in the nest, and so the populations of a lot of these things went down. It was traced directly back to DDT. It also has effects on human beings. And so even though it has a great cost benefit, it's very good, it has a great benefit in the fact that it can treat harmful mosquitoes and decrease disease. There are costs to that from the standpoint of the ecosystem health and also human exposure. And most developed nations banned the use of this around the same time, or between 1972 and 1980. There are, however, a lot of countries that not only still continue to use DDT, but continue to manufacture DDT. In fact, DDT is still manufactured in the United States. It just can't be used as an insecticide. It's shipped to other countries. It's not a highly acutely toxic pesticide to mammals, although if you get it in significant enough amounts, it can be because of neurotoxicity. It is still used worldwide to control insects and harmful mosquitoes that carry malaria and other disease. DDT is relatively inexpensive to manufacture and sell, and so it continues to be used in those areas where the cost of the disease maybe outweighs the cost of the environmental impact in saving lives and decreasing malaria. And again, it is obviously, and was and is credited with saving millions of people from death from malaria. It, as an organochlorine compound, as we talked about, it concentrates in the fatty tissues of the body, whether it's a human body or a fish or a mammal or a bird. And it has an estimated half-life of approximately 10 years. For those of you not familiar with half-life, this means that at any given concentration or dose, half of that will be gone in 10 years, then half of that more gone in 10 more years. So it stays around for quite some time, and typically at levels, as we've found through analysis, that can be very detrimental to the ecosystem and human health. And I think I mentioned this earlier as well. Everything that's living right now on Earth has some level of this pesticide because it is so widespread in the environment, and it travels so far, and it travels through the food chain, and it persists in the fatty tissues of animals who live a long time. So you can measure, even though DDT was banned in the US and a lot of other countries in 1972, there are still measurable levels in the adipose tissue of whales, which tend to live decades around the world because of the essentially ubiquitous nature of it in the environment. As far as human health goes, DDT has been linked to a variety of cancers: pancreatic cancer, non-Hodgkin's lymphoma, breast cancer, It's been linked to reproductive effects, impaired lactation in women, decreased sperm counts in men, and impaired neurologic function in human beings. Now, we think about this, and we'll talk just a few minutes about those things in the environment, organic chemicals we consider to be endocrine disrupting chemicals, or we'll talk about those, but DDT falls in this category. So there are other effects when you talk about DDT other than just these. It can be linked to the reproductive effects and some of the other things, but very persistent in the environment, and a wide range of effects that it has. The category of pyrethrins or pyrethroids, and we'll talk primarily about pyrethroids, but the pyrethrins are derived from natural sources, certain varieties of chrysanthemum flowers. They have a phenomenal ability to paralyze and kill flying insects. They interfere with the transmission of certain neural impulses. For those of you with any kind of neurophysiology or neuropharmacology, they work on sodium channels and essentially paralyze neural transmission. The pyrethroids are synthetic analogs of the pyrethrins. You can still buy pyrethrin containing insecticide. Again, derived from the flower. It's all natural, but it works very effectively to kill these. The problem with the pyrethrins, even though they're very effective, is they have a very short life of action, and so they break down rapidly in the environment. And in developing the pyrethroids, the goal was to make something more persistent that would kill the insects for a longer period of time, that would remain on the crops or in the house or on the pet or what have you, and kill the pests for a longer period of time. This is just a pretty flower in the middle of the lecture to show you where pyrethrins come from. And so these compounds are pretty potent, and so when you see formulations of them, they'll generally be a very low concentration of the active ingredient. For example, I was using something for treating horses the other day, and it's got a pyrethroid in it, and it's like less than 1% of the total formulation is the active ingredient, and so you don't need much of these to kill the bug. The nice thing about these is acutely, they are very benign to mammalian species. They're very toxic to fish and aquatic things, but they're very benign as far as mammalian toxicity goes, acutely. Now, there are some chronic effects that we should talk about in a few minutes. You can use these in the home. As I mentioned, we use them on pets, and they're used on livestock, and they're used both internally as well as externally to get rid of mosquitoes and ticks and things, and they're used widely in agricultural and urban pest control to get rid of a variety of pests in those settings as well. And so the primary exposure pathway is going to be inhalation as a result of some kind of spraying of these, but you can also have ingestion when they are used on food crops or things like that that may not be properly washed. But again, their persistence is not long and not wide. Here's some examples. Ivermectin, this is a very widely used in treating livestock and domestic animals for both external and internal parasites, but primarily external parasites. And again, just an example of the structure. It's very complicated, but you'll see there's a number of those benzene rings, there's oxygen, there's carbon, and there's hydrogen, and that's really all that is involved in these. But they're very complicated structures, and ivermectin is one of the first synthetic, very effective first synthetic pyrethroids put on the market, and it's still used quite a bit today, but the way it's built lends itself to a longer persistence in the pyrethrin. There are a number of examples of pyrethrins and pyrethroids, but just understand the difference between those and, for example, the organochlorines and the organophosphates as far as what they're used for, what their chemistry is about, their persistence in the environment. And so one of the things I didn't talk about before we go on to the herbicides and defoliants is the pyrethroids, the synthetic pyrethroids persist in the environment, and even though they're not acutely toxic to humans and other species, there is some indication that they are associated with certain kinds of cancer and certain potentially immunosuppressive effects. So herbicides and defoliants. Again, remember the general category of pesticides has a lot of things in it. So we've talked about insecticides primarily. Now we're going to move into some of the other categories, herbicides and defoliants. So the herbicides are those things that kill plants. And they can be weeds, they can be grasses, they can be almost anything. Some of the examples in this category of herbicides are atrazine, paraquat, and something called Agent Orange, which is a combination of two herbicides, 2,4-D and 2,4,5-T. Agent Orange was used during the Vietnam War, and also not just in the Vietnam War, but it was used very widely as a very powerful herbicide and defoliant. But during this period of Operation Ranch Hand in Vietnam and Laos, 19 million gallons of this was sprayed over 3.6 million acres in an attempt to decrease the cover where the soldiers could hide and fight from. Interesting, and we'll talk about this in organic chemical section a little bit later, but Agent Orange, as a byproduct of its manufacture, also contains small amounts of dioxin. Some of the health effects, and the Institute, this was a long-going controversy and is still not completely resolved. However, the Institute of Medicine concluded after a number of years post-Vietnam, actually quite a number of years, that Agent Orange was in fact associated with several forms of cancer. And this led, there are so many claims, health claims in the Veterans Administration in the United States about health effects that couldn't be really associated. Finally, some large studies were done, and the association with these cancers, and now with other health effects in U.S. veterans who are part of, from Vietnam, who were part of the Operation Ranch Hand. And so within the VA, there is an entire Agent Orange branch to deal with potential health effects due to that exposure of those veterans. These herbicides are a category that a general category that are somewhat problematic. Their toxicity to human beings acutely is pretty non-existent. However, the chronic effects, as we see with Agent Orange, can be a number of these categories. And if you go back here to atrazine, atrazine is one of a category of Agent Orange of herbicides that are widely used. These are widely used in agriculture, and so to facilitate not having to weed and manage crops and things in fields in that fashion, spray these herbicides, which it won't damage the crops, but will kill all the weeds, so it allows the crops to grow better. These things are fairly persistent, and they've been shown to last long enough to get into the groundwater supplies in many, many areas that are pretty significant agricultural areas and contaminate the water supply. Being that they're not acutely toxic to humans, of course, initially we thought that there were no health effects. However, over long periods of time, it appears that a lot of those triazine herbicides, which atrazine is one of, are associated with longer-term health effects, both reproductive health effects, some developmental health effects, and as with Agent Orange here, the association of certain kinds of cancer. There's also some evidence that indicates they may be affecting the cardiovascular system with respect to hypertension. There are a number of other categories of pesticides we call biopesticides. These are derived from natural materials such as animals, plants, bacteria, and certain minerals. Some of these are more toxic than others. So from the mineral category I mentioned earlier, copper arsenate. And there's a copper arsenate solution that was widely used for many years, Bordeaux solution, and you can still get it today and use it, that's sprayed on fruit trees and other things to kill insects. Nicotine, I mentioned, was used for many, many years as a natural pesticide, and also in harvesting fish. You put a little bit of ground up tobacco leaves in a stream and it'll paralyze the fish and they can be collected. Some trivia there. There's microbial pesticides and plant-incorporated protectants. And so there's a wide variety of things that could be called biopesticides. And the only reason I put it in there is because we've been talking primarily about organic compounds, or synthetic organic compounds that are man-made. there are a lot of other things that we're looking at now to try and reduce the use of that, and here's some examples of things that can be used, even though they have their issues of their own. So who's at risk from pesticide exposure? Basically everyone. We think about agricultural workers, we think about children, we think about pets, livestock, wildlife, and we always think about sensitive subpopulations. Pregnant women, children were mentioned already, the elderly, the immunocompromised, those with other chronic disease stage such as respiratory disease and things like that. And so we need to be very discreet, because if you think about it, the term pesticide, the side part, means to kill in Latin. And so essentially these are designed chemicals that are going to kill something, and we need to be very careful about them, both the use of them currently and in the future. So now we'll move into the second half of this particular lecture, which has to deal more with organic chemicals and solvents. And so these are different from pesticides in many ways, although they're related to pesticides, because most of the pesticides that we've been talking about are synthetic organic chemicals. So we'll talk about some different categories, and we'll talk about some of the environmental health and ecological health impacts that we might foresee by looking at these different classes of chemicals. And you always want to be thinking about your use of chemicals, no matter what they are, how you can reduce your use of chemicals, and what are the costs versus the benefits, both to your individual health as well as public health. So we're going to talk about organic chemicals now, and we'll move on to organic solvents. So solvents in particular are kind of specific, but are also general in their different structures. We refer to a liquid substance capable of dissolving other substances. The solvent itself does not change in forming a solution. So what does that mean, and why is that important? Well, you think about something like a solvent, and this can be even something as simple as isopropyl alcohol can be a solvent. When you use it to remove something, not as an antimicrobial, but remove a stain or something like that, the solvent itself does not change. That's just kind of an important concept, because it relates to the persistence of these things in the environment to an extent. So solvents, because they are liquid and they are typically fairly volatile, that means they evaporate fairly quickly. The biggest mechanism of exposure is by breathing the vapors, although we'll see there are certain classes where they get into the water supply, and drinking water can be a significant exposure as well. We ingest them in foods and in water. There are trace amounts of these due to manufacturing processes and disinfection processes and the packaging. And that's the next bullet, using foods that are packed in certain types of plastics. And there's some great examples of this, I'm sure most of you are aware of, that we'll talk about a little later, where certain types of plastics, because they are considered to be a solvent or an organic chemical, and because of the manufacturing process used, can actually provide exposure to human beings and the environment. Smoking cigarettes is exposure to solvents because of the process used in curing the tobacco. If you work in an industrial situation and you're using solvents at all, you can have a chronic exposure. You can inhale vapors released from industrial facilities. What is this? This is essentially the ambient air pollution that includes organic chemicals, and these are regulated, as we talked about in the fall, regulated under the Clean Air Act in the United States, about the amount that can actually be in air that we breathe. And then, as I mentioned, drinking groundwater that is contaminated with certain classes of these persistent organic compounds. Volatile organic compounds, I mentioned, these are the ones that evaporate very readily in the air. Benzene, toluene, methylene chloride, methylchloroform. Here's some other examples of things that go from a liquid state to an airborne state, not gaseous, but evaporate into the air pretty readily, and that's the primary pathway of exposure. Tetrachloroethylene, trichloroethane, trichloroethylene, toluene, acetone, and benzene. These are some names, and we'll talk about specific examples of these a little bit as we go through the lecture. There are a lot of these compounds that are used in manufacturing plastic. One of these is styrene. Styrene is widely used in the manufacture of resins, which are intermediaries for the manufacture of many types of plastic. You have short-term exposure through inhalation to these that can produce central nervous system effects. You can also have irritation of the respiratory tract, and styrene is one example of something that is possibly carcinogenic in human beings. Vinyl chloride is another example of an organic chemical, volatile organic chemical. Now, this is interesting because it's been used in the manufacture of polyvinyl chloride, otherwise known as PVC, and this is hugely used in piping, plastic piping, vinyl siding for houses, plastic coatings, and upholstery. And this has been classified as a human carcinogen. And so the other thing is plastic wrap that you might wrap your food in, and also formerly, not anymore, but look for those Ziploc bags that are without vinyl chloride or without other organic chemicals. And so it's ubiquitous. We're surrounded by these things because they're manufactured, or their use in manufacturing of so many products is around us all the time. Those are a couple examples of how we get widely exposed. Now, we talk about benzene, and benzene is one of those classic compounds that led us to the understanding of solvents and organic chemicals as a potential human health impact. And benzene has been associated with specific kinds of leukemia, respiratory disease, and other things. And so these are the category is very broad and very wide, but just understand that their exposure is primarily through inhalation. It can be ingestion, and most of what we worry about is a chronic exposure related to carcinogenesis. I mentioned dioxins earlier when we were talking about the herbicides and 2,4 and Agent Orange, and I said that these are byproducts of certain industrial and non-industrial processes, usually involving combustion. So we typically think of dioxins as the byproducts of incomplete combustion. So what does that mean? So in an industrial process, if you're heating something up to make a chemical reaction happen, and it gets heated incompletely, or there's just a leftover part of the process, it can form these compounds, especially when you're working with chlorinated compounds at high temperatures. These things can be produced. Why is that important to us? Well, because they've been linked to as trace amounts in a lot of different byproduct processes to a lot of different cancers and reproductive effects. Here's some structures for you, and you'll see these are these benzene rings linked together with a lot of chlorine molecules and a very stable structure, so they persist pretty widely. There are a lot of these that are formed in the manufacturing process, and dioxins are known to be a big family of compounds, 419, but actually only about 30 or so of these are regarded as being the most poisonous or toxic, and those are primarily chronic toxicity. They're very stable, they persist in the environment, and they bioaccumulate just like all the other organic compound, or the chlorinated organic compounds. They persist in the environment. But let me say this about dioxins. They are not just synthetic organic chemicals. It's not only a byproduct of human processes, but it's also due to natural events. So forest fires and volcanic eruptions also emit dioxins into the environment. And so these are some of the things that are natural background. Now, some of the human activities that can produce it are burning of industrial and municipal waste, burning of some kinds of fuels, bleaching of wood pulp for paper, manufacture and application of some herbicides. or Agent Orange, for example, and tobacco combustion, which gives rise to small amounts of dioxin in cigarette smoke. And so, again, these things are fairly ubiquitous, but they are also produced in greater quantities by human activity than they are by natural activity as far as it goes to dose. And there are some classic cases, Times Beach, Missouri, where oil that had been used in pulp and paper manufacture and some other manufacturing processes that was highly contaminated with dioxin. This oil was sprayed on rural roads for dust control and contaminated a huge part of a township in that one case, and also was spilled into a nearby river where it bioaccumulated in the fish and led to further human exposure. So again, just to go back to our fundamentals of exposure, this relates to dioxin or anything else. How long you're exposed, how much you're exposed, how often you're exposed, and the route of entry. And when we talk about health effects, chloracne is a very specific chlorinated hydrocarbon exposure. So there's this weird, very prominent acne condition that doesn't just occur on the face, but all over the body, the back. And if you have an association with chlorinated compounds in dioxin in particular, then this can be diagnostic to an extent. Skin rash, skin discoloration, growth of excessive body hair. Why would that happen? Well, as we'll talk about in a little bit, dioxins are one of those compounds classified as endocrine disruptors in the environment. Liver damage, possible cancer, we saw some of the effects. Endocrine effects, that gets back to the endocrine disruption, reproductive and developmental effects. So these are kind of classed as iconic chlorinated hydrocarbon toxic to the environment compounds. Another category you may have heard of are the polychlorinated biphenyls, or PCBs. The two most common uses before they stopped manufacturing these compounds was as insulating fluid in transformers and capacitors. So if you drive around and you see on a power pole a canister with wires and things coming out of the top, or the big electrical transmitting stations, in the past, the way they kept the heat down from the transfer of electrical power was to immerse all of those circuits in polychlorinated biphenyl containing solution, typically an oily solution. And so when those old transformers were disposed of, they leaked, and they leaked PCBs into the environment. They were also used to a lesser extent as a lubricant because they worked very well as a lubricant. But the primary occurrence of these was in transformers and capacitors for electrical transmission. So PCBs are also ubiquitous in the environment, and they bioaccumulate because of the way they're structured in fish and other animals and also human beings. So you can have a direct impact to human beings, you can have a food chain impact to human beings, and as mentioned above, they're no longer being manufactured, and the removal of old PCB containing transformers is under a lot of regulation and scrutiny so that they don't leak out into the environment. So here is a slide of a polychlorinated biphenyl. And as you now know, the number of chlorines, or the presence of chlorine in any kind of organic chemical structure, makes it very resistant to breaking down by normal environmental or metabolic processes. And so here you have a highly chlorinated compound with very stable ring structures that bioaccumulate very readily in adipose tissue and persist in the environment for quite some time. We talked about the national priorities list back in the heavy metals discussion. This is the EPA's list of hazardous waste sites around the country in the U.S. That they prioritize to deal with, and the list of contaminants. And if you remember back to that list, PCBs were on as many as 500 of the 1,500 sites. This is a little bit dated because the last number was around 2007, and so those number of sites has probably been decreased. However, PCBs, because of the spillage, they're ubiquitous in the environment and their usage. And so because of the concerns about that, in the US, the manufacture of PCBs was stopped in 1977. This is another one of those compounds, though, that if you sample out in the environment, and especially in the animals in the environment, you can still detect PCBs. They persist a very long time. They're highly resistant to breaking down. And so if they're highly resistant to breaking down and they persist a long time, that means they can continue to create adverse health effects, such as we know that they cause cancer in animals. They're probable human carcinogens in humans. There are also fairly well documented impacts on the immune system, the reproductive system, cognitive development. And one very interesting aspect of this is there may be some association based on an immune response to the Epstein-Barr virus and other viral and bacterial infections, in that the ability of the immune system to respond to these things is limited by the presence of polychlorinated biphenyls. Another category that we talk about quite a bit that are significant in the environment due primarily to human activities, although there are some natural sources like with the dioxins, are the polycyclic aromatic hydrocarbons, or PAHs. This is a group of well over 100 different chemicals that are formed during, again, the incomplete combustion of hydrocarbon fuels, oil and gas, garbage, and other organic substances like tobacco, and interestingly enough, charbroiled meat. They can occur in the combustion of gasoline and diesel fuel. Why do we list charbroiled meat here in specific? Because a lot of the outdoor cookery or restaurant cookery of meat around the world is either by natural gas, or a more significant source is by charcoal or wood. And it's found that the incomplete combustion, because it's not a highly efficient burning, it's burning wood or it's burning charcoal or coal, can release these polycyclic aromatic hydrocarbons that are essentially then taken up by the fat in the meat and are eaten by the humans or whoever eats that charbroiled meat as an exposure pathway. So there was quite a controversy a number of years ago about when the entire craze of outdoor grilling and barbecuing became big, of are we exposing people to more and more polycyclic aromatic hydrocarbons through the prevalence of this pathway. I truthfully believe it's relatively insignificant, but it is something to be aware of if you're concerned about those things in your personal diet. So here's a slide that shows you some of the more significant polycyclic aromatic hydrocarbons and their structures. And as you can see, they're not highly chlorinated like the PCBs or the dioxins or some of the other compounds, some of the pesticides we talked about. But they're built in these uniform or linked ring structures that make them very resistant to natural metabolism processes or in processes in the environment that will break them down and make them into their constituent pieces of carbon, hydrogen, oxygen. And so anthracene, benzoate, pyrene, these have varying degrees of carcinogenic potential, but just to show you the wide variety of things that can be associated with polycyclic aromatic hydrocarbons. So finally, we're going to talk about something that we've been indicating throughout the lecture, and this is environmental estrogens, or endocrine disruptors. These can come from a wide variety of the things we've talked about as far as organic chemicals: chlorinated hydrocarbons, pesticides, dioxins, PCBs. And some of these have estrogenic-like activity. hence why they're known as endocrine disruptors, because they disturb the natural metabolic processes associated with endocrine hormones, estrogen and related substances. DDT and some of its metabolites are called endocrine disruptors. And that means that basically it or any of these compounds act as an antagonist to estrogen or androgen, replacing it in the normal hormonal cycle. This is a huge, huge issue because there have been a number of studies that link the onset of in puberty and menstruation in young girls has decreased in the past 30 years by approximately 5 to 6 years. There are other effects that people are linking these environmental estrogens or endocrine disruptors to because they are so ubiquitous in the environment. They, as stated, can have or appear to have very abnormal influences on the reproductive systems of humans and animals. We can see some of this in some of the sentinel organisms that have been studied, such as certain frog and snail species where sex has been changed, not fully developed, etc., because of the exposure to these things in their environments. These can also act, and we know this is true of all these categories, as cancer promoters. And if we remember back to some of the toxicology from fall, cancer develops in stages. There's initiation of cancer, which is the change in the genetic material. There's promotion of cancer, which is having that one event move on to influence multiple cells through replication. And there's progression, which is having it move from a non-malignant state to a malignant state. And so many of these compounds have been shown to act as cancer promoters by influencing the onset of female cancers thought to be caused by estrogenic activities. We know now that this is actually expanded to also include male cancers and in human beings. So it's a big topic and subject to a lot of research and very related to our discussion of the exposome, in that we are widely exposed to these things in our environment, either involuntarily or through personal choice. But it's something to be very aware of because it could have very long-lasting impacts on overall human health. A slide of some chemical structures again. And so in the middle in the box, you'll see a naturally occurring estrogen hormone, 17-beta oestradiol. That's the natural form. Now around it, you have synthetic forms or derivative forms of estrogenic-like compounds. DDT, one of the isomers of DDT to the left. Nonylphenol, which is found in a lot of plastics and pharmaceuticals. Diethylstilbestrol at the bottom center. If those of you who are not familiar with DES, this was used as a anti-nausea and pregnancy drug and was discontinued because of the very bad side effects with birth defects and things like that, related reproductive effects. Dibutyl phthalate, this is a plasticizer compound, and for many, many years was found in everything from water bottles to plastic wrap to surgical tubing, and it helps in the creation of the flexible plastic. These tend to leach out over time, and the use of phthalate compounds is decreasing. Some of them are actually not used anymore at all. And then PCBs, which we were just talking about. If you also could add this to this slide, you'd put the dioxin structure in here because of its similarity and its known effects as a endocrine disruptor, environmental estrogen compound. Or BPA. So this essentially, and now you can see every product that has anything to do with plastic claiming it's BPA free. This is one of those compounds that was very significantly linked to endocrine disruption, hormonal effects, potential cancer, other reproductive effects, and so it has largely gone the way. But it took intensive study and intensive regulatory action using the scientific evidence to make the public aware of this, make the manufacturers aware, and actually decrease the use of bisphenol A or BPA in products that we have. So that's kind of the last thing, a very current topic, with BPA free being labeled on many food products, or not food products, but packaging products and water bottles. It's not just things from the past that we are dealing with now, it's things we're discovering now that we have to continue to deal with from the standpoint of environmental health and human health and public health and our individual health. So thanks so much for your attention. I hope you enjoyed this, and we'll look forward to the next lecture.